In this video, we're going to go over some of the problems that we did in class today. So we're talking about functions and how they are transformed from their parent function. So one of the problems we had was f of x equals radical x minus 4. Now, you'll notice that this negative 4 is not attached to the radical on the inside here, so it's very important in a second here. Now, my parent function is radical x. The reason I know it's radical x is because this 4 attached to it is only attached to it to change whether it's going up, down, left, right, it flips, or becomes steeper. So I know that just the original x, and whether it's a square root or an absolute value function, that is what is my parent function. So the radical x is my parent function because everything else that's attached to it or multiplied by it is what is transforming it. So again, I know my parent function here. So if I know that's my parent function, and I notice I have a minus 4 out here. Well, if you remember from your notes, we said that if we multiply a number by x, then that affects the steepness, whether it gets steeper or wider. A negative flips the function. If you have a change inside the parentheses, or in this case inside the radical here, like if I had a plus 1 in here with this radical, then that would move it right or left. And to the right is a negative sign, and to the left is a positive sign. If my change is outside the parentheses, or the radical, or whatever it is, like in this case here, then a positive moves it up, and a negative moves it down. With that being said, that means this function moves down 4. So we know from the parent function that our function up here moves down 4. So if I know what my parent function looks like, which you should all know from your notes, looks something like this, the radical function, then I know that my domain, by looking just at this, going from the left, starting here at 0, and then I'm going to go forever to the right, so that would be infinity. So that would be my domain for my parent function. And then my range, if I start at the bottom, starts here on the y-axis, which is 0, and you'll see that my graph keeps going up and up and up. Here, just keeps going up. So that means my range is also 0 to infinity. So that's for the parent function. Well, I know that this transform function moved down 4, so I'm going to take my vertex here and move it down 4. So it's going to start here now, and it's going to look the exact same. All it did was move down 4. So if I know it moved down 4, then that's going to affect my range. And the reason that affects my range is because moving down means I go along the y-axis, which is the range. So my domain is going to stay the same for f of x. So my domain is still 0 to infinity. But my range, again, because I moved down 4, my range is now going to start at negative 4 and is going to go up to infinity now. So this was my domain and range for my parent function. And this is my domain and range for f of x, the transformed one. And again, that's how I just use my parent function to figure out what the domain and the range are for my transformed function. And the reason that I know that only the range changed is because my transformation, I only moved down 4. I did not move left or right at all. Let's do another one. Let's say I have f of x equals x minus 6 plus 2, where x minus 6 is in my absolute value. Now, your problem from class has a 3 out front here, so I guess we can add that in. I have a 3 out front. So if my absolute value function here is what I'm dealing with, then I know my parent function is an absolute value function. Again, we also know it's just a regular x, because this 3 that's being multiplied affects the steepness. The 6 that's on the inside of my absolute value, or inside the parentheses, moves it left or right, and this plus 2 on the outside moves it up and down. So all this extra stuff is extra stuff. So that means my original one is its parent. So I can write down my transformation here. Again, I multiplied by 3, so this steepness is affected. So it becomes steeper. This 6 that's on the inside is a minus, and if you remember from your notes, a minus on the inside means it moves to the right. So this function also moves right 6, and this plus 2 on the outside, if you notice here, moves up 2 then. So now I can draw a little sketch of an absolute value function, and again, this is in your notes, that bright yellow paper we have. My absolute value function is going to look like this, where I have my vertex, again, at 0 here. So if I know it got steeper, that really doesn't have anything to do with the domain and the range. So I'm going to focus on this right 6 and up 2. So I go to the right 6, which would be out here, and up 2. So my new vertex is right here. So I went right 6 and up 2. So this is my parent function, and this is f of x. So now I can use that graph to help me figure out the domain and the range. So if I'm just looking at my parent function, my domain, you'll notice, this is going in both directions. It's going to the left, and it's also going to the right. Unlike the radical function we did earlier, which only goes in one direction. So this radical only goes to the right. But an absolute value function goes to the left and the right. So the domain for an absolute value function is negative to positive infinity. And again, this is the parent function. The range for my parent function, range is the y-axis and found from going from the bottom to the top. So if I look at where the bottom of my graph is, at 0 here, so I start at 0, and my absolute value, even though it's going to the left and the right, that is domain. If I'm looking at range, I'm focusing on what it's doing on the y, which is going up. So I go up to infinity. And that's my parent function. Now my transform function, that f of x, since I moved to the right 6 and I moved up 2, that's going to affect my domain and my range. Because right has to do with domain, left and right, and up has to do with the range, which is up and down. So I know my domain and my range are going to be slightly different. Now, if I look at this little sketch I draw, though, I can see that my domain actually is not different in this case, and the reason it's not different in this case is the same thing, that this is stretching out to the left and stretching out to the right. So that didn't change at all. Even though I transformed it, that didn't change. So the domain for f of x is also still negative to positive infinity. So again, even though I moved to the left and the right, that didn't change this because the domain goes in both directions. My range, however, did change, because if you look at where this vertex is, now it starts at 2. And the reason the range starts at 2 is because I moved up 2. So my range is now from 2 to infinity. Now if I were asked if it's increasing or decreasing, like we asked in class, that is where this right 6 is going to come into play. If I look at my absolute value function, the f of x here, not the parent, just the transformed f of x, it starts increasing if I start over here on the x-axis, because increasing has to do with the x-axis. Right here at 6 is when my graph starts increasing. So my increasing interval is from 6 to infinity because it never stops increasing in this direction. And you'll see if you compare that to the parent would start at 0 and go to infinity. But again, I moved over right 6, so now my increasing starts at 6. Well, that must mean that my decreasing is on the negative side, going to positive 6. And that's all for those two examples.